start recording this webinar so we can have a look at it later. And again, my name is Trevor Brown. I'm Business Development Manager at Juniper Systems, and I'm joined also by Ryan Pearson. He's our Utilities and Public Services Account Manager, and he also has a lot of experience working with local government and deploying field data collection projects. All right, so the title of today's webinar, Inexpensive Sub-Meter GPS Options for Local Governments. And here's the agenda for today. We're going to try to keep this to a short webinar for 30 minutes or less, and we'll save some time at the end for some questions. But please, during the webinar, please write on the GoToWebinar chat dialog box, please write your questions there. We'll try to address them during the webinar. However, if we don't get to them, we'll certainly follow up in detail. We'll also be recording, as I mentioned, this webinar, and we'll make it available to anyone at the end of the webinar so that you can look at it again or share it with others. So here's the agenda for today. We're going to start with a brief introduction of Juniper Systems. We're then going to have a look at the Mesa 2 rugged tablet, as well as the Geode sub-meter GPS receiver. So those are the hardware devices that we're going to be talking about today. And then we're going to look at using those hardware devices with software and workflows that are common for some of our customers within local government. And we're going to look at 3 typical examples. One is a traditional GIS workflow, kind of an alternative to Trimble type systems. The other is an ESRI-based workflow using their Collector application. And the final one is a form workflow. This is the area where you can replace paper forms and convert your data collection to electronic forms. All right, so Juniper Systems introduction. We are manufacturers of ultra-rugged field data collection handhelds, and our factory is in Logan, Utah. We design and manufacture all of our handhelds here. Logan, Utah, it's based in a mountain valley in far northern Utah. If you don't know where that is, it's kind of near the Idaho border, kind of en route to Jackson Hole, Wyoming, and those areas. Our parent company is located across a cow pasture. They are Campbell Scientific, and they are a world leader in manufacturing data loggers where their customers attach all kinds of sensors, things like weather stations and all of that. So we work in a number of different markets, everything from agriculture to natural resources to local government, municipalities, state governments, for example, as well as military and industrial type applications as well. Again, all of our devices are manufactured at our factory in Logan. We have a very low failure rate, and we are among the highest in the industry. And we are very committed to quality on all of our devices. We are a relatively small company. However, we do have a presence throughout the world. We've been in business for about 20 years under the Juniper Systems name, but since the 1980s under other names. However, we do have partners in over 80 countries, and we are, in addition to our factory in Utah, we have an office in the United Kingdom, as well as an office in Kansas City, Missouri, and in Austria, serving our agriculture customers. All right, so the hardware that we're going to be talking about today, the Mesa 2 rugged tablet, as well as the Geode sub-meter receiver. Okay, here's the Mesa 2. This is our newest handheld that we're manufacturing. It has been in production for about 6 months now, and our factory is definitely busy with all of the positive feedback and demand that we've had for this unit. It is a Windows tablet, so a full Windows tablet. So just like your desktop or laptop, this is something that's running Windows 10. You can dock it using a docking station and have it connected with a monitor and a mouse and all of that. But then when you're ready to go out to the field, you can take it out and undock it and use it as your mobile device in the field. It is running an Intel Atom processor. It is it's about 1.8 gigahertz, and it has a lot of memory and storage. As with all of our devices, they're meant for the field, so they're meant to have a full day's battery life. As you can see here, the battery just pops up and pops out, and you can put a new one in there, just kind of like a flashlight. You can have an integrated additional battery capacity, which gives you an extra 4 to 5 hours. So it gives you that hot swap capability. And with all of our devices, everything's made ultra rugged. So it's meant to work in very hot, cold temperatures meant to be dropped. They can even be submerged in water. Dust, dirt, humidity, all that stuff is certainly things that that our customers experience, and that's why our devices are made ultra rugged. So the display, very high visible display in sunlight, and you can run metal across this. We don't even recommend screen protectors. It does not scratch. We use a chemically strengthened glass during our manufacturing process. So very important feature for us is a high visible display that is ultra rugged. As I mentioned before, everything we build, Juniper Rugged, comes with a 2-year warranty. Many customers end up using our devices for 5 or even 10 years. It's very, very common. So we are IP68 rated, MIL 10, standard 810G, if you follow those ratings, but basically meant to be used in hot, cold, very rugged environments. Ready for anything? You have Bluetooth, Wi-Fi, options for cell modems, barcodes, and RFID. They do come, our GPS models come with 8 megapixel camera as well. This is a geotag camera, as well as a high performing GNSS receiver inside of the device. All right, the next one is our Geode sub-meter receiver. So this is a very accurate receiver. It works well in open sky, and I would say best in class based on our testing under challenging GPS terrain, such as under a lot of dense tree canopy or in urban canyons near buildings and all of that. We're seeing very good results, and our customers are seeing very good results in those environments as well. It's also affordable. It's among the lowest, or it is the lowest sub-meter accurate GPS device that we are aware of, and it's costs a lot less than the next competition that we're familiar with. It's all in one, meaning that it has an antenna and a receiver all inside of the Geode. It doesn't need extra cables or connecting external antennas, although you do have an option to connect an external antenna, but those are typically used in more fixed mount type scenarios. So it's compact. You can see in the woman's hand here, it's pretty small. It has an open interface, meaning that it can work with any of our handhelds, but also any of your own handhelds that you might already own. So any Windows device, any Windows 10 device, and any Android device. It does have an option to work with Apple or iOS. It does require a small little attachment, but it's commonly used with Apple as well. Does have an all-day battery life as well, and is super rugged, just like all of our other devices as well. And there are several ways to mount the Geode. These are the common ones that we see customers, how they carry this device. So it can be used on a survey pole here, used with typical RAM mount attachments. There's a magnet. You can put it on a magnetic mount. Let's put it on vehicles or ATVs or things of that nature. This is one of my favorite. It's just an inexpensive camera collapsible pole. So this is a $15 collapsible camera pole that I like to use with inside of a backpack, but you can also extend that and use it kind of like a monopod. So here would be the monopod example. Here's the one I was talking about, where you can take that pole, collapse it, and put it inside of a backpack. Usually I get a backpack that I attach it onto the side, but that way you can just have a hands-free data collection. So this Geode is connected to that Mesa 2 via Bluetooth, which is very simple to do, and you can just collect your data like that. We also have a smartphone tray where you can use the Geode. It just attaches right like that, and you can use it around as a device just held in the hand. And I just want to talk a little bit about accuracy before we look into the local government workflows. So here's a very basic test that we did, typical, just using a 60-second average. These circles here, as you see, are 1 meter radius. You can see all of the positions lining right up inside of these. And again, this is not a survey technique where we let it occupy a point for a long time. This was just a basic 60-second average for each of these points. You see them all landing within the 1 meter. This circle here, when we drill down and look at the data, this circle is actually a 1 foot radius, or 0.3 meters. So as you see, the majority of points landing within this 1 foot radius, and those are based on the NSSDA standards, which is 2 sigma, so 95% confidence that the Geode results will land within 0.5 meters. Okay, if you choose to post-process the Geode, which many of our customers in local government like to do, you can get much better accuracy, about 10 centimeter accuracy. And there you see the orange box. That orange box represents the size of the Geode receiver. So that's the receiver itself. So it's post-processing to a very high level of accuracy. All right. So now we're going to start looking at the kind of majority of our webinar now and focus on the workflows that are common within local government. And the first one we call the traditional GIS workflow. And in this workflow, you have, this is really an alternative to, like, for example, Trimble that a lot of customers are familiar with from the past. And so this is a way to kind of save a lot of money and against those traditional GIS workflows, but have, kind of replace what you're currently doing with something that we feel is a more premium device, but something familiar with your users' data collection processes. So in this workflow, we really are looking at planning your project from the beginning. There's a period of, then you just collect your field data. If you want, you can post-process your field data. And then in the end, you upload your data to a GIS. So on the right, these are the different tools that you use in the process. So for example, you can use either ESRI ArcPad, which is a common one from the past, or my preference, which is EasyTag mobile software. And this is really an alternative to Trimble TerraSync, where it gives you many of the same features with the addition of a few others that I really like. And then the hardware that you use is the Mesa 2 rugged tablet, along with the Geode sub-meter receiver. And so this would be, versus kind of some expensive Trimble alternatives. And the last one, if you are post-processing, you can use EasyServe post-processing software versus the Trimble Pathfinder Office. Okay, so in that first step, planning, there's the option to create the custom data dictionary. So this is where you have the ability to kind of define what attributes you want the users out in the field to be collecting. So you can, after they collect either a point, polygon, or line, you can have them guided through a series of questions and attributes that they need to answer about that feature. So in this case, in the customer, maybe they're mapping fire hydrants and they would select this, and this would guide them through a series of questions that you want to have answered about that fire hydrant so that you can load that information into your GIS. So it's a way to kind of standardize how your field data collection is made, as well as making it very easy for the users to collect the data. So you can upload your own high-resolution maps in common file formats if you choose to do that, but you can also just clip maps from the web and have those as layers on the mobile device so that the customers have some imagery in the background. Finally, if you choose to, you can copy some shapefiles from your GIS to the Mesa 2 so that those are additional layers in the background. So in this case, we showed some parcels there that would be common in local government. So, and then the next step in collecting your field data, we then are just out in the field. And if you'll notice here, you have these attributes that you defined in the data dictionary. The user would simply choose the one that they're going to map, and then it would guide them through those questions. Once the data is collected, if you do choose to post-process your data, the first thing I always tell customers is don't be intimidated by all of the icons that you see on this EasyServe software. You really don't need to use most of those. It's a professional surveying software, but for local governments, you really only have about 3 steps. The first, you import the file that you collected out in the field. You then push the button for post-processing. And it will post-processing then, it will automatically go off and search the closest base station, reference station that's in where the data was collected. So this is the way that your data set will go from the real-time accuracy of 30 to 50 centimeters in open sky, or if you're in a challenging environment, post-processing really helps to kind of clean up any kind of error that you received, down to about a 10 centimeter result after post-processing. Once you're done with that, you then have the option to just export your data into various file formats such as CSV, or use to open with Excel, KMZ and Google Earth, shapefiles, or even AutoCAD DXF. Okay, here's a cost comparison. So with the typical competitor type setup with Trimble, we know them to cost about $9,200, $9,300 for all of the software and hardware. With this setup that we're talking about, it's really only about just under $4,300 for that setup. So you can really save a lot, and there's not additional subscription fees or anything as well. There's some tips that we have to save even more money. So if real-time accuracy is not needed, you can just collect data with the Mesa 2 and post-process that data and get sub-meter results. So if you don't need to have the real-time accuracy, if you're just wanting to make a map that's sub-meter accurate, then you can just use the Mesa by itself and post-process your data and save even more money. Another tip that we have is if you have more than 3 devices, you don't need to keep paying for the post-processing software if you are post-processing. You can just buy an open license and download it as many times to as many computers as you want and post-process as many handhelds as you want as well. So that can save you if you have more than 3 devices. Finally, if you really are looking for a budget option, and you're okay using an Android device, we do sell Cedar Tree Android devices, or you can use your own Android device, and then you can just get the Geode sub-meter receiver and pair it with that, and for example, use Mobile Data Studio software or some other, and you can be saving a lot of money going that route. Okay, next I'm going to turn it over to Ryan, and he's going to talk about an ESRI-based workflow using the Collector application.
Thank you, Trevor. For those unfamiliar, the ESRI Collector application is offered free to the current ESRI ArcGIS software users. It's a part of the ArcGIS online subscription service from ESRI. Alternately, the ESRI Collector application may be used with the ESRI portal product if you have a server in-house. All ESRI software customers who are current with their software maintenance are entitled to an ArcGIS online account and the associated applications, including the Collector application. I'm going to present today on the workflow associated with successfully using the Collector app within the ESRI platform. Basically, there are 5 keys. Trevor, do you want to go to that next slide down? There are 5 keys to successfully completing a project using the Collector. These 5 keys are listed on this slide. I'll talk about each of these 5 keys later through my portion of this presentation, but I want to introduce them at this time. To properly execute a mapping or data collection project in local government, it is critical that proper planning occur, that the necessary resources are available to build the project, that the project is shared appropriately to the organization, that field work is properly supported, and that the project be supervised and monitored, providing opportunities for adjustments to be made. As I mentioned, we'll talk about each of these 5 keys on these subsequent slides. On the next slide, properly planning an ESRI Collector application is presented. The importance of planning an ESRI Collector project cannot be overemphasized. Perhaps this is the single most important key to successfully completing any field mapping project. The first step to planning involves clearly defining the purpose of the project. Once the project's purpose is defined, the project method becomes easier to develop. Based upon the project purpose and the project method, it is important to identify the required resources needed to successfully complete the project. These resources include personnel, IT infrastructure and resources, field technology tools like the GPS and field computers that Trevor just described. As a project is being planned, it is always wise to set project milestones and to measure progress, especially when working cooperatively with other departments or even other outside agencies. These milestones help local government organizations see that the project is being completed successfully. On the next slide, we'll discuss the steps needed to build the project. Using the ESRI platform, there's plenty of tools for us to design map projects, to design applications that can be used by field technicians. The tools are available to quickly build a solid collector-based application using the ESRI platform. This includes a combination of tools in ArcGIS Desktop and ArcGIS Online. Designing a proper database schema is an important key to the project. This schema could be of your own design or could be a publicly available database schema. ESRI's published a lot of different data models that could be used as part of your project, for example. It's important to also evaluate data that already exists that might be used properly in your project as a key to building that project. To build your project, you want to start with the tools in ArcGIS Desktop by selecting a map, publishing the map services and feature services to be used by the collector application. This is a simple process once you've built a map that will be used in the project and you've selected or designed the proper database schema for the project. Lastly, you'd use the tools in ArcGIS Online to modify the collector app to meet your data collection needs. There's lots of resources online on how to modify and adjust and build these collector applications at the ESRI website. Once you've built the database schema, selected your map, and developed the app that will be used for data collection, you're ready to begin your actual data collection project. On the next slide, we'll talk about sharing the project to the work group. So we've using the tools in ArcGIS Online and the ESRI resources, we've developed our application. Now it's time to share this application to our work group. Once a project is shared to the members, I should mention this is done very simply in ArcGIS Online, just sharing your project. Once a project is shared to the members of the work group, you may want to test the project through a pilot program or employ other testing methods to make certain that the application, the personnel, and the field technology meet the expectations defined for the project. By testing the application, the field technology, and the workflow, the manager can make certain that the project is simple, efficient, and complete. On the next slide, we'll talk about the data collection process. Once the ESRI Collector project is built and has been tested, it's time to put boots on the ground and begin to collect and update data. During the data collection process, it is important that the project manager supervise and coach the field personnel. This gives field personnel confidence and allows the manager to monitor the progress of the project as well. Based upon progress, the manager may assign specific tasks to members of the work group using these ESRI tools. As the manager coaches the field personnel, methods to increase efficiency may be revealed too. If the project is properly planned, the proper resources are in place, and the field personnel are properly coached, then the ESRI Collector data application project will be rapid and accurate. On the next slide, I want to discuss the importance of project supervision. Constant supervision of the project during the data collection and mapping phase is critical. Supervising the project will reveal opportunities to improve the workflow, will build the confidence of the field personnel, and will help ensure that the project is being completed as designed and as intended. ESRI provides tools like the operations dashboard that you see on the screen to monitor the progress of ESRI Collector projects. I think it's important to provide regular updates to members of the work group, especially if you're working with other agencies or other departments. Being able to demonstrate progress to all the stakeholders builds trust energizes the group, and builds momentum for collaborative future projects. If the project is progressing very well and solid results are being realized, share that information with others. It is okay to promote the success of the project. This emphasizes that the ESRI Collector project was planned correctly. On this next slide, I want to describe the advantages of the ESRI Collector solution and also a few items to consider. In my opinion, ESRI is a fantastic collaborative tool. That might be its greatest strength. The Collector solution allows projects to be prepared and deployed rapidly. Work can be reviewed in near real time. The ESRI Collector application provides great flexibility in workflow and the technology platforms used in the field. Some of the challenges we've already discussed on previous slides. Without proper planning and execution, the project can fail. The project may fail without proper resources being available or a general lack of organizational support. Planning properly and including stakeholders in the process will overcome many of these challenges. Properly selected field technology and position accuracy limitations could negatively affect the project as well. The project may be derailed by choosing the wrong field equipment, even when other aspects of the project are executed well. On this last slide, I want to talk about the field technology. Some of this is a repeat of what Trevor's already described. It's important to consider the equipment that you're taking to the field. This includes the platform and the operating system. If you do choose the wrong equipment, it can be frustrating to field personnel, the very people responsible for most of the work. So consider the field PC platform and operating system, whether the peripherals are required like barcode scanners or a camera or laser rangefinder. Consider your accuracy requirements, your network connectivity, and the durability of the equipment that meets your demands in the environment. This has been presented already, but I just wish to re-emphasize our new Mesa 2 rugged tablet PC and the Geode GPS receiver as fantastic options for successfully completing the ESRI Collector project. With that, I appreciate your time. I'll turn the controls back over to Trevor at this point. Thank you.
All right, thanks, Ryan. Okay, now we're just going to have a quick review of the last workflow in today's presentation. We call it the form workflow, but basically this is just a great way to replace your paper forms. And you can integrate the Geode submeter receiver if you are taking spatial data as well. So I'm not going to review each one of these details, but basically on the left you have your paper method where you have a process to kind of create your field notes on paper, record your data in the field, and you might integrate things like GPS, barcode, or photos, or things like that, and then kind of manually enter all that data back at the office into a spreadsheet. We're going to focus on the right side, which is using a rugged tablet application. So with this type of workflow, the process is you basically, instead of creating your paper form, you have the ability to create your mobile app. And what I like about that is you don't have to be a programmer or IT expert to be able to create nice, user-friendly applications for data collection. And down here, you then capture your data using that electronic form in the field. Good thing, you can keep your data protected. It's on a device. It's not on a paper form. It's on a rugged device, by the way. But you're also standardizing how that data is collected. You can integrate with all of your other data, like your GPS, your barcodes, your photos, and all of that into your data collection process. Finally, when you get back to the office, it's very simple to then synchronize back to a database. So you no longer have to manually enter your data from a paper form into a database. There's ways to kind of synchronize that or just export it to common formats like Excel. And then once you do that the first time, you can repeat that over and over again. All right, here's a quick example. This is Salt Lake County. They have a paper form that was used to collect their stormwater inspections, stormwater assets and features. And basically, what they've done is you've created an electronic form using my favorite form software called Mobile Data Studio. So what you see is each one of these gray sections on the paper form there's things that the user was filling out. We've just transferred those onto, or this user transferred those into different sections of the app. Once the user clicks each section, it will bring up a screen that has the associated data. So this is just recreating that paper form onto a nice user-friendly mobile app that can be used with the Mesa 2. It can be used on Android. It can be used on Apple or iOS devices as well. Okay, so in creating that first part, when creating your app in the first place, when you buy it, you get this little application designer. And this, again, is very easy to use. Takes a little bit to figure out, but this is the screen that you would see when you're creating your app. You click this add button, and then there's all these different types of data points that you can add to your application. So many options, many different types of data collection this can apply to. Okay, again, there's the paper form that we're recreating. Once you're done with it, the most important point is to test that app. Have a period of testing before you send it out and live into the field. Once you're out in the field, the user can then just follow the screen and fill out the information as they collect the data. And you can also, right within your data collection on the device, you can integrate taking photos, a GPS, where you connect the Geode, for example. You don't have to use the Geode, but it's great to get higher accuracy. You can integrate barcode, RFID, rangefinder, signatures, a lot of other little features there that are quite handy. And then back at the office, it's very simple. Once you get within Wi-Fi range, or if you're using a cell modem, but most people are using Wi-Fi, the data then just can automatically transfer to this little internal database window where you can see all of the records that were collected in the field. You then have the option to export those into common file formats such as Excel, HTML, XML, Google Earth, KMZ, or you can integrate nicely with external database. So you can set it up where it synchronizes directly with an existing database. All right, so if we look at the price of this kind of a setup, you have the Mesa 2, you have the Geode receiver, so premium hardware at really good prices. I mean, these are meant to last a really long time. And then you have your mobile data studio that costs only $200, and you can create as many apps as you want. Gives you that desktop application generator plus one mobile license. If you want an additional mobile license for other devices, it just then costs only $100 per device. And those aren't subscriptions. Once you buy them, you own them. So that's a really good way to kind of replace your paper forms, collect high accuracy data, all for the price of just under $3,300, and that's with the long warranty as well. So really, that's the end of our webinar today. We hope that you learned some good options to collect sub-meter GPS accuracy field data at budget prices, and all that's done while using premium hardware. We back up everything that you have. Every customer that we have has free live technical support, so you can call and talk to a live person at our factory. So you have free support. In many cases, we can help you with your deployment or help you, assist you in getting started. So if you have any questions, please be sure to just write them in your chat GoToMeeting there. We'll be sure to follow up on those if we haven't already. Also, we really like these kinds of projects, and if you have questions or want to get our suggestions with or without our hardware, we're happy to help you and discuss your data collection projects. So we hope you learned something today. If you do have any questions, or want to contact us further about your specific data collection, feel free to contact either Ryan or myself, and we'll follow up with you, and we can even have a look at your own data set. So again, I'll leave this open for a little bit, and we will be sending this recorded webinar out. So have a good rest of your day, and thank you.